Hare Krishna. Hope you're doing well. Let's get started with this question on convergence of a given sequence. So, there is a question about convergence and also a question about what's the nature of successive differences between the terms. Is it positive or negative? And all we will need is a knowledge about sequences to solve this. Okay, let's start with intuition. Now, the question is asking whether the successive differences are positive or negative. It is focusing on two specific terms. They have a habit of bringing in the year in some way or the other. It was in 2025, so they brought it in. But in general, it's about the differences. So we can take the general difference of two successive terms and notice that xn minus 1 is written like this. The reason being, it can be factored in with this 2 by 3 over here, and we have a form like this. And in order to study it more analytically, we just take it as an equivalent function dx. I chose the letter d because d for difference. Now, our intention is to check whether the difference would be in general positive or negative. It's a starting point. Later, if needed, we will come to specific values as well. So we try to see the analytical conditions for which this difference, the general difference, would be positive, and we come to this condition. Now, the thing is, notice that you have variables on both sides of the inequality, and when you make adjustments, it's very crucial to remember that when you are multiplying with a negative variable, the sign changes. And the second thing is, our starting point in the sequence is a negative entrance. So this may be something we shouldn't be concerned about. So if the input is negative, then the only way successive difference would be positive is if this condition holds. This is essentially telling that whenever, before minus 2 in the number line, whatever value of the sequence that you take, let's say like minus 10, right? The next term in the sequence, when you take the difference, it is going to be positive. So for everything before minus 2, it will sort of, the difference would be positive, which means it will go towards the positive direction. And notice that when it is exactly minus 2, the difference becomes 0. So when, if there comes a point in the sequence when uh, the value of the sequence becomes minus 2, it will keep on, it will just stay minus 2. So that is the thing, but that doesn't completely answer our question. We uh, actually, it kind of gives a very strong indication because it has to be either positive or negative, and we just established in this particular event of things it is positive. But if suppose that was not the case, the way to check that uh, whether it will be positive, negative, or zero at this particular point is to notice that when you say start with minus 10, the next value in the sequence is minus 6.5, which is getting closer to minus 2. But we analytically check that the only way this general sequence structure can be equal to minus 2 is if the input is either minus 1 or minus 2. So again, it is going in the direction of minus 2, but it is never actually going to touch minus 2. It's just going to get closer and closer and closer. So this would give us the guarantee that this, had it even been x22, this minus x1999, whatever the appropriate 9, it would also be greater than 0. So this analytical check helps us with that. And naturally, because it's going towards the direction of -2 and it gets closer and closer, it is going to converge. Now, notice we didn't use this famous monotone convergence theorem, though it may have been brought in a particular way. But going about it in this, starting with the general difference, because that is what was being asked, that helped us to solve it smoothly. A pitfall could have been taking this difference function and trying to find its derivative and trying to work with the derivative. That could be a time consuming affair. We start simple, just check whether the general difference is greater than 0, which means positive for some simple set of conditions or not. If that doesn't work, okay, then let's go to the derivative. But if simple things are working, why complicate it? That's all. Take care. Hare Krishna.